This all this relates to wearable technologies and the advancements in AI that we see. So the way I've structured my talk, just so that you get an overall picture, because we'll be spending the next possibly 1 hour together. So maybe you can, there are areas which you might already be strong in, maybe some areas you want to tune out or tune in based on your interest. So I'll focus on the advancements in AI, like I said, and then I'll focus on few foundational technologies that drives this advancement. And so this part is very important. And then I'll focus on my area of specialization, which is bioacoustic signal processing and implementation of all these techniques that I'll be covering in the first two sections of my talk. And fourthly, I'll try and drive all the points that I raise. I'll try to link it to the theme that or I'll talk about possibly the technology behind that enables wearable technology and how it is a really promising area to be in, based on the disruptions that are happening in multiple other areas, which contributes to development of this technology. So, as some of you must have noticed, I have mentioned the title as Advancements in AI, and I have mentioned a particular company called NVIDIA. Now, the reason why I've done that, so we see a lot of, obviously none of us are uh, unaware of the advancements in AI, because it is all over the news today. So if you look at the last maybe just the last 3 4 months, you would see I don't think anyone would have not noticed what is happening. So irrespective of that, it is very hard for us to navigate through what is uh, is going in a structured way and what is disruption and what is happening around. So what I've done is looking at all the major players who are working in this area. If you look at Meta, if you look at Microsoft, OpenAI, right, Google, and all these companies, they they do have a base or the backbone of what drives their disruptions or what drives their advancement is the company NVIDIA. So if you look at 2023 and if you look at 24, you'll see that NVIDIA has been the official GPU supplier for Meta, Microsoft, Google, Amazon, and every other company who's working in this technological areas. And I do not know about others. I have not honestly been following what NVIDIA has been doing for some time. But I think it came into view, or it came in picture when we started seeing that NVIDIA became the most valuable company in the world with all the disruptions and advancements happening in this area of AI. Right? So these are all very recent statistics put up. And so the way I would structure my talk, focusing on the advancements in AI, uh, I will try and talk in line with the vision of the NVIDIA's vision, and specifically focusing on one of the address that they have done recently. The CEO of NVIDIA had spoken. Jensen Huang has given a keynote speech at the Consumer Electronics Show that happened in Las Vegas this January, just last month. So January 7th, that event had happened. And at that time, what was the trajectory, or what was the advancement or the vision in which, because all the other companies that you see, OpenAI included, all the companies that you see, they are their clients, right? So they all work together, and so they can see where technologies are going and the competitions that are happening. So all this is true up till Jan 7. And then, as we all know, there has been a disruption because of DeepSeek, and so I'll mention that at the end as well. But for better sake of clarity in terms of structure, we'll focus on what has been the trajectory and what has been the vision. Right. So if you look at all this started from 2012, when AlexNet, one of the basic neural net model, came into existence. So a lot of research had been done in that area. Possibly many of us who are faculty members, we would have started working on what we call as a perception AI. Maybe we did not use that terminology, but all the machine learning analysis that we do, the models that we have built, the evaluations that we have done, had been possibly with machine learning, and then we moved on to deep learning, and we have done some studies there. And I'm sure there are faculties who have worked on more advanced levels as well. Uh, but I think a majority of us would have been in on the perception AI. And then if you see what has come next is what you call as generative AI. And at a face value, I found it, honestly speaking, I found it hard to see where this will find application in healthcare. And over looking into the technology and being objective about it, because every time we look at generative AI, we look at something that is fancy that is put up on the internet. We look at deep fakes. We look at things that that beyond useful parameters. We look at things that like something that is creating that is not real, right? And so how can that relate to something as scientific and something as structured in the world of research? And so, but generative AI has a huge application, and so that is what I'll be elaborating on in this talk as well. And what had come after that is something called as agentic AI. So agentic AI is a huge disruption in how these technologies are being used, and uh, how even industries will start running from now on. Right. So agentic AI is so I'll be talking on that, some of the tools that are used, and I'll mention them in the use cases as well. Beyond agentic AI, there are some advancements after Jan 7 that has happened as well. So we do have operators now that are there. There is deep research for all the faculty who are in academics. That is an area that we have to look into. Like years spent into research that we had done is I mean, I wouldn't say it's possible or that it is replaced, but definitely there are systems now which can actually aid us into uh, reducing that time to make a head start in the research that we want to work in. All right, so I'll keep the structure in place, and I will talk about different disruptions. I'll focus on the theme of this particular talk, and so this is there on YouTube. So the faculty, when you get time, you can actually look into this particular keynote address by NVIDIA. So looking at generative AI, possibly we already, maybe if you look at Midjourney and some of the products that are already there, you can see that you can type in a text and a text actually generates an image. Or there are even, you can generate videos as well. And so there's a lot of disruption happening in that area. There's a lot of industries that are going to be affected, affected or, supported by the aid of these technologies. Just basically looking into the system, if you have fundamentally you have a 3D structure which is designed, a layout of a place that you want to build, and then you have all the control parameters as to because the scene has to be logical, like the forces of gravity, wind, certain natures, guiding principles has to be in place. Yeah, otherwise, it will not give a realistic feel. And so once that is built, these images are once those guidelines are given, these images can be generated directly. You can even pick and replace items, specifying that I want a fountain at the center, or I want a more of a tree or more of a summer layout. So all these applications are something that we are familiar with, and some other application that possibly we are already familiar with. I do not know how much we look at it from that perspective. That would be like an option that I've shown here is the dental report. Right? So if you look at the uh, dental report here on the right bottom corner, this is just a sample report that possibly you go meet your dentist, and at the end of the visit, you get a report. So this is not particularly only for dental. For any other for any other conditions that you go for a diagnosis, you would have gone for yourself, for your parents, or someone that is in need of healthcare support at that time. So looking at this report, if you look at, for example, I'll just possibly read some of the statement. Look at the patient exhibits generalized mild gingival inflammation with localized periodontal pocketing of up to 5 mm in the posterior region. A tooth number, meaning a particular tooth, uh, present with a deep carious lesion involving the pulp, confirmed by periapical radiolucency of radiographic examination, moderate callus deposit, and uh, plaque accumulation are noted. And so you have a very formal report like this, and so sometimes what we do So this is just an example. If you look at other reports that you take, generally the technical terms are really hard. So what we generally do is we would take this report, we would go to a family doctor or someone who knows this condition better, and then we ask them, please tell me what happened to my family member. I can see the data, but I don't understand. Right. So this is where generative AI can be used extremely well. This can be done both by the patient and it can be done by the healthcare provider as well, which means that the doctor can also uh, have a formal report and can have an informal report, which gives the patient the confidence and the assurance that is needed. So simply just writing a prompt saying that rewrite in 3 sentences in simple word for understanding and assurance of the patient. So it just says that you have a mild gum inflammation and some plaque building up in a deep in a deeper infection in tooth number that needs treatment. An X-ray shows an infection near the root. So we recommend the root canal cleaning and better oral care to prevent further issues. With proper treatment and regular checkups, your teeth and gum can stay healthy. Right. So this is a very brief summary of what the patient needs to know, what the patient should be assured about before he goes in for the next visit. And I think generative AI, we've been using ChatGPT for different purposes to summarize, contents paragraphs. Medical reports will find a huge application in this area. So generative AI is very much in line with what this is one of the applications. There are other applications I'll highlight as well, but it is very much in line with what uh, uh, yeah, on making patient care more effective. So the interaction between doctors and patients gets much more closer once this interpretability of the reports starts getting better. Next, I would like to talk about agentic AI. So this is just like an entire company. For example, there is a person recruited by the HR. He has come inside, and he is looking for a particular software development role. So, uh, so that particular agent, for example, the first picture on the left, is actually trained on maybe 2 or 3 tools specialized in that particular area, and that agent is then defined to be a software engineer. There is someone else who's going to be a machine learning engineer. There's someone else who's going to handle, data at the backend and the cloud infrastructure and all that. So all these functionalities are going to be defined as separate agents, and they are going to be trained and specialized in that particular area. For example, areas of finance, areas of accounting. You do not have to have a general model which knows everything like ChatGPT to have queries asked. You have dedicated AI agents which will be built in for an organization. And more interestingly, what agentic AI is very capable of is that once it is structured, once it is defined, you do not have to individually talk to each agent. So you would put out a requirement saying that my client requires, a particular product of so and so features within this particular deadline. These are the tools that they're using so that, once we build the product that they can integrate into their systems. These are the constraints, these are the budgets. So once, that statement is given, there could be an AI manager which will actually spread out all the work. So these flows can be defined prior because each organization, who talks to whom and how does the hierarchy go. So these structures can be defined, and as per requirement, these agents will talk to each other, get the work done, refer whichever source is required, and as you can see, this is one of the biggest disruption that has happened now, and possibly this is one reason why there is a lot of concern. Industries where people possibly could lose jobs. So when you have 100 people, possibly maybe 5 people or 10 people, once the systems are effectively, or industries are actually already working on this. So once it's already in place, or once it is established in place, a lot of jobs will come into question. And not be skeptical or not be negative about it. We have to try and understand this trend. So we are in a phase where we are looking at trends or a change in trend that is happening, and like within the umbrella of what you call as advancements, and how do me and you adapt to this particular changes. So this disruption is happening now, and and something that is a little bit more uh, difficult, meaning in the sense that like just because someone has 10 years of experience in a particular technology doesn't mean that he has. So I've been talking to some of my friends in the industry, especially people working in machine learning and those areas. So they have spent 10 years working on TensorFlow, PyTorch models. They had to, understand different packages, how it integrates, how this has to be handled. But within the same company, when a new joinee is hired, Now they are asked a different set of questions. It's not something that in depth that they actually took like 6 months off to sit down and try and understand the system. In short terms, what mean to say is that the barrier to entry to get into industry now is much more less, which means that more people can actually access this technology. So the technology required a lot of knowledge to actually get into it, but now it is more accessible. So once the barrier of technology reduces for you, the barrier of technology reduces for everyone, right? So that becomes a huge challenge, and the requirement has also dropped down. So these are some challenges that we will face in terms of employability. But looking at it from a positive light, looking at it in terms of productivity, this is a fantastic, an advancement that has happened, a huge disruption that has happened, and it's ongoing. So if you look at one example that I posted, just a press release that came in Jan 13. I do not know how many of you know IQVIA. So they do a lot of clinical research studies, and so NVIDIA they have an office in Bangalore as well. So NVIDIA is in collaboration with them to develop these systems to have more advanced agentic AI solutions, right? So this is something that we will have to look out to. We'll start hearing about a lot once industry start adopting. So as part of the keynote, our speaking wants to talk about physical AI. So which means that again, Facebook, Meta, and every other company like Google, they want to bring AI into the physical real world that we live in. So everything that is happening now is happening on laptops, is happening on some cloud server. Right? So there's a lot of processing that is required, a lot of power that is required to run these processing units, and so in centralized servers and all that. But they want this AI to be something that is part of the world that we walk around, and the world that we live in. So one great application that they spoke about is something called as a physical AI. So this is where you have huge warehouses. So irrespective of whichever domain products that we talk about, the product is generated in one particular company at a particular location. They could distribute. They could distribute at different areas, or they can have production units at multiple areas. But I mean, you cannot have infinite number of factories. So there is going to be a huge amount of packing and shipping and storage at different places before they are transported to different areas. And handling all this manually is a huge challenge. Manually takes a lot of time. Manually takes a lot of resource. It is not an easy job as well. And so what they've done is they have tried to map an entire uh, a warehouse, the structure of a warehouse. You look at how each aisle is positioned. How does one a carrier mission actually move to different sites? How are they numbered? How can they actually localize and go to a particular point and pick up a particular package? So they call this as an omniverse, in which like the previous example, like I said, you have to have a ground to truth reality, which means possibly the limitations of the entire warehouse, the restrictive movements that the missions can have, and a mapping of the entire area. You create something called as an omniverse, and then you create something called as a cosmos, which is actually more of a digital twin. This entire study can be done. You try and see how a mission actually navigates to different part of the warehouse. How can this be done effectively? How can this be done in the shortest time? How can this be done very accurately? And like you can see on the top right, there is a lot of agents which will continue to work at the back end. At the bottom right corner, again, irrespective of the domain, but since our theme is on healthcare, you can look at huge amount of equipments and drugs which are shipped across the world. Have huge amount of a huge number of warehouses as well, and all this will add to the logistics cost. If you can do it effectively, you can bring it much more quicker. You can bring and you can bring down the cost as well, and so all that will have an impact on healthcare as well, because that is our theme. I'll touch upon that as well. The next that I spoke about is autonomous vehicle. So again, this is another a huge advancement in AI. So this has been a talk for a very long time. So there are some missions that are working effectively well within campuses, like Google's campus has their products. In terms of healthcare applications, they will have a huge impact on the uh, the automobile industry, sorry. But in terms of healthcare, there are pods in different countries where they have, like possibly where there's an elderly patient who needs to travel from home to the hospital, and requires that kind of an aid. So there can be a mission which is a driverless mission. There are separate tracks in these developed countries, roads with which this missions can navigate. And um, and these advancements bring in much more patient care. So it is not true in every country that the parents are taken care of as they grow old, be it in India as well and other countries. You do see that the parents have to figure out ways for themselves. And so these kind of autonomous vehicles and autonomous vehicles with support systems or one attendant inside, these are all different products that are there already in the market. I mean, in specific regions wherever this is implementable, right? So there is a lot. There's a long way for this to work out. There are going to be some challenges in case it's an emergency condition. You cannot possibly rely on the system. So that has to be figured out. But this is a huge advancement in technology, and so that will have an impact on healthcare as well. And and the ultimate vision for every industry here is to have uh, like a clone version of ourselves. That has been a vision. You look at all the books that you read, the stories, the movies, and everything has been talking about this one particular direction in which technology goes. Where you have robots which can understand you, which can do the work that you do. So physically tiring work that we do not want to do, we want robots to do it for ourselves. So they have come a long way in robotics as well. So you look at countries like Japan and China, they've been already deploying these robotic systems for elderly care. So to take care of their condition, to help them navigate around, all these bots are already there in these countries. And if you look at the demography, it is different. We have a much more younger growing young population, and I think in China and Japan they have a much concentration on the elderly population now in these years. So it is much more harder for you know for a government to actually take care of the elderly population, and it's complicated as well in terms of economics. Like there is a working population that actually contributes to the taxes that is earned by the government, and for the government, they have to have systems in which they can take care of the uh, elderly population, even though they cannot expect a revenue generation from them. Right? So multiple governments has to sit together to figure out these systems. But again, in terms of healthcare, there is a huge application. So again, like I'm saying, there's someone else doing both an autonomous vehicle and physical AI and robotics. There is a technology being developed for some other application altogether. They are focusing on something else, but that developments are actually driving or shaping the way we look at healthcare, and it is evolving our field as well. Right? One of the last products that they launched was something called as Project Digits. So if you look at the system at the bottom, just like a small square box, this is a full supercomputer that NVIDIA has launched recently in this consumer electronics show. And so they have just stacked two boxes just to use them in parallel if you want to use it more effectively. And if you look at areas like drug discovery, um, there's a huge amount of computation that people have been doing for a very long time. It's not something that a computer science engineer can just go in and fit in few models and get the answer. There's a lot of in-depth domain knowledge that is required to build these systems. And these kind of supercomputers are definitely enabling good research labs to build really good to have really good computation at much more cheaper cost. So NVIDIA drives this research. So now looking at all this, you can see that more people can get into access this technology, more people can um, access the computation as well at much cheaper cost. Now focusing on just the foundational technologies behind these systems. If you look at the first disruption that I think we saw was a transition from our perspective, at least, a transition from Google to using ChatGPT, right? So I don't think we ever imagined that we would actually stop using Google. So there are a lot of web pages that we relied on. We go there, we need to know the source, and that is how we've been, getting all our information. In ChatGPT, now the entire approach has changed. We do not want to go and find the right web page. We just need the information, so it reads from everywhere. And I do not think that once you use ChatGPT that you would go back to focusing on Google pages and all that. So that kind of a disruption happens, and that basically happens fundamentally looking at how humans communicate is by building language models, right? And so this is very much in tune with the uh, developments and advancements that happens in healthcare, because a lot of data that you see, like I said when I spoke about generative AI, a lot of data that you see in hospitals are stacked in huge reports, in huge patient data, patient history that we do not analyze. Now a lot of hospitals do digitize this, but how can we move further from there, right? From where, like I said, generative AI can be used as a uh, can give a good interpretation of your condition. And so we have to, even though even I worked on audio application, I worked on different applications, but foundationally, if you speak, like if you think about it, language is going to be the fundamental way in which we communicate, and language is going to be a fundamental in which the systems are going to understand us as well, right? To provide a service. So the first basic description, if this is not an area that you have already worked in, and this is new to you, so this is something that is new to me as well. So I have not worked on text much. So I prepared more in line with the since the topic and the talk came up. Um, but this is a very interesting field from the time that I have started learning. So if you look at text, so it's been hard for me to understand. Like when I look at audio signals, I know I can extract features. I know there are different feature vectors and this feature space and all that. But when I look at text, it was very hard for me to comprehend as to how does computers understand text, right? Because they understand only numbers, and so it was hard for me to relate when I had no insight into it. So we have to look into how language is actually built, and I'll give a small introduction into this technical topic. So there are certain pre-processing that you'll have to do. So we communicate in sentences, and so if you look at uh, and and we continue the same idea into paragraphs and articles and much bigger chapters and segments that way, right? So you have to define something called as a token. So a token is just the fundamental unit that you will have in a written article. So that can either be a sentence or it can be a word, and from then on, there could be certain pre-processing that is required. How this is converted into numbers is what I'll try to show. Uh, so if so, it is okay. I'll just show a small example here in Jupyter Notebook, uh, if it's possible. Uh, can someone, so can you clarify if you're able to see this page, or are you still seeing my presentation?
It is visible, sir.
It's just okay. Thank you. Right. So this is a simple. In Jupyter Notebook, I try to understand how these systems are built. At certain pre-processing that we do there before we, give them into systems. So NLTK is one second. Just one second. Yes, I hope it is. Yes, so I think you're able to see I have a little header for the Zoom link. I'm not able to see the tabs. So I'll try to show this to you. So what we call as a sentence or a paragraph is, in technical terms, is defined as a corpus. And so in this case, I've written out a statement, welcome all to the AICT Training and Learning Academy, sponsored faculty development program on transforming healthcare through wearable technologies and AI. So I'm John Amos. I welcome you to my session on advancements in AI and bioacoustic signal processing. Thank you for participating in this ATAL FDP. I wish you all the best. Right. So this statement I take and I define it in what we call as a corpus. So corpus is going to be any document you read in a PDF document into the system. A natural language processing model will understand the content of the PDF as a corpus. And from the corpus, you create something called as token. So you'll hear this word so lot. Like you have to pay this much, this, like $1 would cost, will give you this many tokens to access. And these terms of token you're going to hear a lot. So a token could be a sentence or it could be a word, depending on what fundamental unit you want that system to run on. So what I'm using here is what is called as a sentence token. So NLTK is natural language. It's a toolkit. There are a few other toolkits as well, but this is quite easy to use. So you have something called as NLTK tokenize, and you can import something called a sentence tokenizer, which means that it takes a paragraph, maybe possibly because of full stop or different ends that you can define or spaces that you can define. You can actually break down a sentence into different tokens, right? So what I'm doing here is I am passing in this corpus into send tokens, and I'm saving that into documents. And each sentence in the document, I'm printing it out, right? So now what I've got is from a corpus, I've moved into something called as sentence tokens, right? So my first sentence here, the full stop entered here. Then the second sentence started, I am John Amos. That has become a separate sentence. Thank you for participating as the third. And I wish you all the best as the fourth. Right. So similarly, what can be done is you can have something called as a word tokenizer as well. So a word tokenizer would actually break down the entire sentence here, as you can see it. Right. So each word in the entire paragraph or the entire corpus starts becoming a token. Right. So it is important to identify what a token is. Now looking at some examples here. Yeah. Now if you look at some examples here called as stemming and uh, so, yeah. So what we've seen here is tokenization. So it is important that you break down the entire sentence or the paragraphs or the corpus into what you call as tokens, the way you define it. So in this case, we have defined it as words. You have something called as stemming. You have something called as laminatization. And just quickly to understand what that is, it like putting it on the PPT will take a lot of time. So if you look at certain examples, it will give you a clear picture. For those of you who have not worked in this particular space, it could give some insights. If you look at words like having, have, had, doing, do, does, right? These words have the same meaning, and based on the context and the sentence, the usage of it changes, right? You eating, eat, eaten, going, gone, and go. But when it comes to word processing, when it comes to natural language processing, we try and look at because these words tend to have the same meaning. These words should be represented with a similar set of numbers when you talk about it. Each cannot have a unique definition to it, right? So once these words are defined, we use something called as a stemmer. So here, what you do is you in NLTK you have a library called a stem, and you import something called as porter stemmer. So there are different types of stemmers. I'll compare two, and then I'll move on to the next one to show a comparison. So you get an idea of what is happening to this data. So if you look at all these words, you try and find what is the root word of it. The root word meaning now having can have the meaning have, right? So have so I have a car. So I've been having it for 3 years, right? So have has the same meaning here. The root word of it is have. In the usage of sentence, we use it differently. So having has the root word have. We have stemmed it to its basic word have as have, but the had is also a past tense, but it has not taken it as a root word. It has taken it as a separate word. Doing is understood as do. Do is also understood as do. Does uh, it's not understood fully, so there is an error here. Eating is taken as eat. Eat is taken as eat as the root word. Eaten is not taken as a the root word eat is not taken, right? So going, go, gone, gone. Gone is again not taken as go. Go is taken as going. So you can see that protostemmer uh, does try to give you the root word. So the idea here is that I do not want to have too many vectors, each vector defining something that is similar as well. So I need to know what the root words are, and uh, and I'll try and give one vector definition to most of all these if they have a similar meaning in the sentence. So that is what we are stemming here for. So you can see that there are some errors here. One other method here is something called as a snowball stemmer. So snowball stemmer would give a slightly better result, having has have had, but doing it does not. Doing it as taken as do. Does it has not taken it properly, right? Eaten it has not taken properly. But if you look at both of these systems, they are good at solving something. Few snowball is good at solving something else. So in this case, if you look at stemming, you can see for words like fairly and sportingly, it's not able to take the right root word. But if you were to use snowball stemming, here it is able to take the root word as fair and sport. So this stemming is very important here in this stage. And possibly one method of uh, doing this right way, we use something called as lemmatization. So in this case, what we will do, so what I'm using here is what we call as lemmatization. So that again is taken from NLTK. From STEM, it is importing a word net lematizer. And so I'm creating an object and I'm passing uh, the uh, the object here, the word, to this lematizer. And in this case, if you look at it, you see that the result has not changed so much. Uh, is going, do, eaten is still eaten, right? Going is still going. So this is not an effective way. The difference is that here you have something where you can define something called as a position, or what you, or noun can be defined as n, verb can be defined as v, adjective can be defined as a. So we do understand that language here is a little bit more complex. You cannot, based on the sentence or based on the usage in that word, uh, it's the understanding and the meaning is going to change, right? So we require what you call as this information. Is it a verb or is it a noun as well? So for a noun, every word is going to be taken the same way. But if you look at the verb, having is taken as have is taken as have, had is also taken as have, right? So because it is a verb here, right? It's an action taken. Doing is taken as do is taken as do, does is taken as do for the first time. Under this method is taken. Eating is taken as eat is taken as eat, eaten is also taken as eat, right? So going on and go is taken as go as well. So here what we are doing is we are trying to find what is called as a root word here. Right? So once you define this root word by using stemming and laminatization, you move into something called as bag of words. So bag of words, basically what it does is, if you have three sentences, small dog, cute cat, cute dog, these are three sentences. You take what are all the unique words here. So if you look at the unique words, you have small, you have dog, you have cute is repeating here, so you can ignore that. You have cat, cute is repeating, dog is repeating. So you have four unique words: cat, cute, dog, and small, right? So looking at the first sentence, small dog. So it does not have a value for cat. It does not have a value for cute. For dog, the frequency of uh, the word dog is one in the first sentence. The frequency of small is one in the first sentence. So if you look at cute cat, cute has a frequency of two and cat has one and the others are zero. Cute dog. So this is one way of representing words into numbers, into vectors. And this is possibly something that can be fed into the model as well. But again, this is a very primitive way of doing it. There is huge amount of zeros and ones in the data that is necessarily not required. So you use for something called as word to vec. So word to vec generally uses a neural network model. It uh, it uses the feed forward network. So what it does is it extracts certain features. And in this case, if you look at these features are actually not defined in data. It takes the feature called as nature, it takes the feature called as cosmos, it takes the feature called technique. So you think that I want to represent how I'm dealing with this data in of size 3. I want to fit it for size 3. So it will take up few abstractions from the data. It exists similarities in difference in the code as the same parts like exclusively explicitly call this as nature, cosmos, and technique. But it will give a definition of similarities. And if you look at parameters, they have plain robots, so they do have some similarities, and they follow the cosmos and techniques. Like fly, eagle, and cloud, there is an inclination towards nature, so that is a different vector value. So this vector similarity or the associative similarity is what again it focuses on. We try to see if one data matches an input data, right? So the cosine similarity or cosine similarity means that we ignore the magnitude, we do not care about the magnitude, we look at the angle. So if the vector has like zero angle or very close to it, it means that we are talking about a plane here. Your input data is a plane. If you were to make a comparison here. Okay. So scaling this idea is what you call as a large language model, and what drives this technology behind is what you call as a transform. So I will quickly go to the ideas, the main ideas behind this, because I do understand we do have a shortage of time here. But the fundamental technology that you talk about here, if you look at the technologies that we have worked on, deep learning models, from then on there had been a huge disruption when transformers came. Right, so transformers, why it has been very significant because of something called as attention mechanism. So attention mechanism simply means that I'm not going to look into every data in terms of sequence. uh, I have the ability to look at what is actually important in the data. I can focus on different aspects of the data, and I'm not dependent that I have to go from the first data to the second data to the third. So I can look at the overall data and I can see which areas I need to focus on, and I can start doing my computations there. Right. So you have something called as a query, key, and a value. So query represents a current processing element, a word, for example, and key can represent all the elements in the input. So if you look at this diagram here, you have query, key, and value, and so they are multiplied. Query and key are a dot product is taken. So dot product will give you a similarity index there, and there is a scaling parameter root of d suffix k, and it is multiplied with v, and a softmax um, um, activation function is used, and you have what you call as a similarity matrix. And so this is so based on this, you get a set of values for q, k, and v, and so these parameters are going to be input into the training data. If you look at the last line here, an updated weights for q, k, and v are going to make use of backpropagation technique to transform to train the weights of the model. So this is a simpler representation of the architecture, right? So there's going to be an encoder and a decoder, and you need to know the position of the text because we're focusing on different area. And another interesting aspect here is that in LSTMs and RNN that you have to work before, you have to work in sequences. You need to know there is something called as a vanishing gradient problem here, where you cannot when it comes to longer text, it's very hard for you to find dependencies there. So here, what is happening is everything is done in parallel, and the computation capability of parallel processing capability of most of the systems now is enabling this technology to work. Uh, so focusing on advancements in AI, the trend there, the foundational models there, I am now moving into my area of specialization and my areas of research that I've done. I'll focus morely from a market perspective. I do want more faculty. I'm sure you're working in different areas, but I do invite faculty to also contribute in this particular area of research if you find it interesting. So the way I've structured here, I will focus on three case studies. As time permits, maybe I'll cut short if required. I understand my session is between two sessions, so I do not want to keep the next speaker waiting. So I do have three case studies, and I'll elaborate on them, personally on what I have worked on it. And I'm trying to look at the trajectory in which NVIDIA CEO saw it. So I'm not going to be a speaker here who's going to say that, I figured everything out in AI, and, I'm here to uh, you know, to say that, I've done it all. So I'm looking at trajectories just as much as you all are looking into. And I'm trying to try and interpret how these, can be implemented in our areas of research, right? And I do, for my interaction with Nitya ma'am as well, happy to know that a majority of the faculty here are from EC as well. So you see, and I'll focus my talk towards the end into the trends that is actually increasing the demand of people working in this space, right? So the first case study that I'll focus on is trying to build a solution for a pulmonologist, right? Um, I think it's increasingly more important now that we have been working independently like when you work on biomedical engineering application, when machine learning initially came, I'm sure you must have heard the hype that we are going to replace doctors one day, right? And so that hype was there for some time, right? There was a lot of uh, not a good word to say, but a egoistic way of looking at healthcare. You do see that the diagnosis part that a doctor does is a very small part of the healthcare service that he provides, right? So once you start working in collaboration with the doctor, you see that there are multiple challenges that happens in a healthcare setting. And just because you can create a model from 93% to a 96% accuracy to say that the patient has a particular condition, that doesn't mean that you can replace a particular doctor. But what is more important now is that we work much more closer to these specialists. So it is a high time that we stop looking at conditions like maybe just calling cancer. There is demand there. Let me work on this. I need to work on someone with a specialist, maybe an oncologist, and try and understand the challenges that he's facing there and the medical products that are available in the market and try and build real solutions around it. So, like I said, generative AI text-based solutions, these solutions are going to have a huge impact. Now, even though I'm sure most of us working in healthcare would have not focused on that particular area of research, right? So, so like I said, that's why I'm mentioning pulmonologist here, the heading of my case study itself. And my focus here is on studying lung acoustics for respiratory care. So, like I said, perception AI is already something that we have done. So, based on limitation of data, you either go for machine learning or deep learning models. So, I've done that studies. And how could we project this for a generative AI or a agentic AI application is something that I'll talk about. So, since I do understand that many faculty would have not worked on acoustic areas. I'll give a brief introduction and I'll give a brief um, um, insight into this domain and the research is happening in this area. So if you look at the stethoscope, this has been a design. This was almost the first medical device that was ever there. And if you look at the physicians who were there at that time, if you look at the analog stethoscopes, if you look at the practices that was done at that time, it was very unhygienic. And so small incremental steps were taken. So earlier there was the field of biomedical engineering did not exist. It was doctors who built up all these tools. So slowly they build small products. You had the monophone, then you have the uh, you had stethoscope models that came after that, very crude models that came after that, and digitization of it happened due to multiple reasons. I cannot possibly cite one person, but for my research, there is one professor by the name James West. He's from John Hopkins University. He was the co-creator of what you call as an electret microphone. So you have condenser microphone, you have other forms of microphone, but something that didn't require a power supply from outside, something that was very cheap and something that was very compatible, was built by James West. He is still like a very senior professor in John Hopkins University, and he has done a lot of research. And his current research is also in this particular area, right? So this is the hardware, and as you can see, there is a FET inside. So the sensing part is going to be a capacitor. So there's a sound wave that is coming inside the capacitor, has a physical movement, and that physical movement changes the distance between the capacitance plate, and there is a the change in capacitance is going to give you a voltage on the other side. And as you know, JFET is a voltage control device, so you do not require current to flow through it, which means that you're not the loading effect is going to be taken care of. Your signal is not going to die out because lung sounds, these sounds are actually very less in energy. So you need to make sure that you have a ideally an input in infinite input impedance, and JFET kind of gives that. So that is already inbuilt into the microphone. This is not a diagram that is drawn separately. If you look at the two terminals outside that is sticking outside of the microphone, it is actually the terminals of the JFET. It is not particularly any of the terminals. So the output that you get from the small device is just the signal that you get post the JFET stage or a small pre-processing stage, right? So I think from then on, you had MEMS based microphones that are being built, and you came into what you call as the digital stethoscope market. So this is hugely there. There are so many products now in the market. Um, so Think Labs, Stetomy is a Canadian product. Accurable is a really impressive product. So this is built in the Imperial College of London. They have a wearable electronics lab there. They have a microelectronics lab there. A few labs in collaboration had sat together to work. There was a ma'am, I'm not able to recollect her name. It was under her guidance that her research team had actually built this product, and they came out and formed a company called Accurable. So Curable makes that looks like a small Vicks bottle, but that is the size of the stethoscope that is actually there now, right? So they use that for different studies for different researches, and but these are all products that are now available in the market, and these are the Indian version of it. Um, IOSync is one, which is very famous. It was built by IIT Bombay. So they have already, if you look at the Shark Tank India version, they got few crores of funding there as well. And the products they focus more on telemedicine application initially, and their backend team are working on self-diagnosing applications using these devices. Muse Diagnosis is one in Bangalore. So this is uh, a veterinary doctor and a very famous hip hop artist, a musician. They together formed this company, and they are actually not. The product is already in the market, but again, like I said, for telemedical purposes, you have to connect your headphones jack inside, and this can be used. The noise cancellation capability is extremely good, and but automated diagnosis. I had spoken to the company quite some time back, and so they were developing these solutions at the back end. And very recently, they told me they're launching out that solutions as well into their product. AICTE is a very impressive, very well-established product now in the market. It was built in IISc's incubation center. So that is an extremely good product in the market. It is already under clinical testing in and around Maharashtra area. They're collecting a lot of data from that. One other area where I came to know quite recently post my PhD is, and I was not aware, to be honest, till that point, is having a stethoscope, more like a multi-parameter monitoring device. So there are companies which are building products like this, where in remote or rural areas where you do not have access to very high-end medical equipments. These devices to take care of different aspects. You want to look at abnormality in the throat, in the ear, basic parameters that you want to identify, along with the functioning of the lung and the heart. So, as you can see, the device here on the left, there is a stethoscope sensor on top. But apart from this, there are other parameters that it measures as well. So both these companies are based in US. So I've been consulting this company, Medentum Innovations. So they have already built this product. It is now coming out in the market in March. And so the self-diagnosing capability of that product is what the company, I mean, they have already done it. They are trying to make it even better. They have an extremely good team, and they focus on that. TytoCare is a company that has already got FDA approval. It is in the market. So when you look at stethoscope designs, not particularly just devices alone, because now most of the microphones are digital microphones. They are integrated into systems like this as well. So there is a lot of demand, and in terms of opportunity for faculty as well. In terms of consultancy, there are companies in which you can provide your expertise once you know what products that they are building on. Right. And in terms, in line with the theme of our talk, wearable technology, uh, the company that has done the most in this area is Stratos Lab. So Stratos Lab has this kind of a device which you can. They have got an FDA approval for their product, so it is connected onto the body. You can continuously listen to lung sounds and heart sounds, and so sometimes people wonder why that is necessary, because even if you like the pulmonologists that even I meet, and so obviously what is running through your mind is something that I understand is uh, mostly pulmonologist adaptation to these digital sensors has been very tough in the market, simply because any doctor from the time they've been in college, they have throughout the residency, they are very familiar with the analog one, and the doctors who are very senior and all, they have there's a lot of resistance to actually move into a product in which they are not in control. So there are different settings for you to get lung sounds, enhanced sound. So they just want to have it live, and so that is that. Second, the doctors that say I do not make any major diagnosis. I mean, I do not make any conclusive major diagnosis. The stethoscope, I use it only for like a screening purpose. I see something abnormal, I ask them to go take a test. So that's what I'm going to use it for. Why do I need to focus so much on it? But these products that are now coming to the market, they are focusing on taking care of your lung health and your uh, the health of your heart by uh, continuously monitoring. monitoring these vitals. Right? So this is a study that the Stratos Lab company had released. So if you look at the lung sound signals, um, the lung sounds that they have been receiving, you see that there are coughs, rhonchi, and these different types of wheezing sounds that you have. And across the duration of stay and across the post-discharge time, when you continuously monitor, you see that there has been a necessity for the patient to actually come back and take further medication. So this wouldn't have been possible if we had let the patient go after discharge. So this was recognized, and then the patient was readmitted again, as you can see in the last graph at the bottom. So after readmission, you can see that this condition has subsided for quite some time, and it has remained low for the next many days. Right? So there is a huge need for these kind of products, and Strato Labs is one company that is possibly in the forefront of it. So if you look at all the major companies working in this particular area, you can see Stratos Lab, like I said. So there are different segments to it, focusing on artificial intelligence and diagnosis and medical imaging in digital health devices, 3D printing, genomics, right? And Strato Labs is one. Like I said, Accurable is another company here, right? So possibly you can see other companies that you're focusing on. I think the picture clarity is a little low because for the presentation, I converted this to a PDF. But I think you can see different categories and different industries working in this area, which are relevant in 2025. Right. So focusing I focusing on the area of research that I worked on. I do want to clarify to the coordinators. Can I take under 5 to 10 minutes? I see that I've exceeded my time.
It's okay, sir. You can have it.
Okay, thank you. For the sake of time, I'll focus on one case study alone. I'll skip through the rest of it and I'll come through my conclusions quickly. So I think the major points that I want to drive, I'll try to focus maybe only on that. So this is a respiratory study. I am looking at only the mechanical aspect, the mechanical functioning of the lung, which means that structurally I want to see how the lung looks like, right? It is simply like playing a flute or playing a guitar or an instrument, where it has a physical structure and that changes the quality of the sound that comes out, right? So I'm just looking at the lung as a tube like this. I'm not concerned about oxygen, carbon dioxide, all the gaseous, transfer that is happening. I understand that studying these parameters is going to help me with that. So I'm looking at it purely from a mechanical perspective. This is your breathing cycle. If you place a stethoscope on top, if you look at through the airway passages, through the alveoli, when sound propagates, it hits across the elastic valve of the airway passages, and so that is going to create another pressure wave, and the total wave that comes out is what is going to be picked up by the stethoscope. And so this is what the signal is going to look like. You're going to have an inspiratory phase and an inspiratory pause and an expiratory phase and an expiratory pause, and this is how your respiratory cycle continues, right? Um, so these are every one of them ECE. So you obviously can recognize all. So these are chest sounds, and I have denoised my signal to get my lung sound. So that is actually a whole research in itself, denoising. I used uh, we have to be careful that we do not lose out on the information while we try and remove signals like heart sound and other prominent sounds that are there, which we consider as noise in our study. So in the lung sound signal, I convert them to spectrograms. I convert them into short term. Uh, uh, I take short time Fourier transform of it. I convert it into a time frequency representation, which is a spectrogram or a MFCC image. So this is one of the best representation. Even though we give raw data to every deep learning model, converting them into an image and giving it to a CNN model has worked much more better. And so some redundancy studies have done based on what parameter has significance and what not. So this is a simple correlation study. You can do it. Again, this is very close to the areas that I'm sure all faculty do work as well. So simple correlation will tell you if across time is my parameter actually similar to another parameter, uh, or is it different? So if it is unique, that is a feature that you want. If two parameters are similar, it similarly changes over time. it means that I can discard one of the parameter because it is not giving an additional information. Okay, so that is the analysis that I would have done here. I would have done an optimization there. There is some hyperparameter tuning. There are different techniques that you can use, like grid search, CV, meta learning. So this is a basic machine learning model looking at just two parameters, C and gamma, representing SVM models, and trying to find what are the optimal values of this. These hyperparameter tuning can be done, and similar can be done in higher models. The major point that I want to focus on, and maybe I'll go through the rest of my talk later. Like we do talk about a lot of advancements in AI and all that, but it does require some level of domain expertise to actually do a good research. So some areas that you see, especially in our domain, I'm sure many of us faculty would have faced. If you see a lot of people who work extremely well on machine learning and deep learning models, taking up your problem statement and doing an extremely good work in it, and publishing a lot of papers, you see that the papers do come from computer science and people from other domains. Sometimes what happens, people who work in acoustics, I'm not sure if there are faculty, but you would notice that technologies that were done for a long time for speech processing would have been the same technologies that have been worked on lung sounds and heart sounds as well, because those were very well established techniques. There were experts working in that particular area. When research focused on these areas, techniques were simply used over here. Different techniques that are used in for general data, which are not medical data, are directly thrown into these systems. So I'll highlight on certain limitations before I close. One observation I've done here in this study is that looking at since I'm looking only at the mechanical structure of the lungs, I have an observation that a child, an adult, and an elder is not going to have a mechanically uh, is not going to have a similarity in the mechanical structure of their lung, because as they grow at different age stages, structurally it is going to be different. So I'm trying to look within that mechanical structure. Is there fluid? Is there an airflow obstruction? What else can contribute to a different sound that is generated? And sometimes the best thing to do here is to categorize them according to their age. Like if you were to build a general model across all age, there is a variability of the mechanical structure by itself across the age category. So I build models specific for for children. I build models specifically for adults. I build models specifically for elders. Again, the structure of the male and the female one is also different. So if you were to approach a pulmonologist, I have done. If you were to talk, first of all, the idea is that you cannot take a lung sound and perform. You can try and identify, a condition, because I'm not going to use a stethoscope for that analysis. That is simply a preliminary tool that I use. So beyond that, even having a discussion is tough. Again, on top of that, if you say that, I can build a model which works good for kids and adults and elders, and male and female separately, that is not even something that is considered as a discussion. But keeping certain parameters, keeping certain observations in mind, if you look at the models that you build, very basic models, because the amount of data, medical data that you have is very less. You do see that, models built for female models, especially built for children. There's a lot of variability within that small age itself, from 1 to 18, when you take all that data. So you see that if you have outliers like data taken from data taken from adults, if you just remove the data and consider them as outliers and rework on your model, you will get a better performance is what we have observed. So this is one observation, and like I said, there are two things to it. One is because it is machine learning, I got a solution. But second, because there was some domain knowledge to it, that I was able to possibly look at it from this perspective. Right? Looking at so the major study was done for COPD, because looking at wheeze and crackle, it is basically to see which is the leading cause of respiratory deaths. So COPD is the major cause, which is because of obstruction. The second study that is done is, can I place a stethoscope? If I am going to build an automated stethoscope, and I know a doctor is going to keep the stethoscope around 6-7 places around my body. If I'm going to buy digital stethoscope from the market, where do I place it? Is there an optimal position to place it? By any logic, can we find one position where we can optimally place if you're looking for a particular condition? So logically speaking, clinically speaking, this does not actually make so much sense, because sound propagates in every direction, right? They propagate better through sound, through solid medium than through liquid and gas. Well, that is fact. The propagation from a source is like a sphere, so it spreads out in that way. So just keeping a step here or back shouldn't make a difference, but I still did the study. And the studies did show. So this is a radar plot. I have 7 areas here. So posterior right, posterior left, lateral left, anterior right and anterior left, and the trachea. Kept across these positions, I try to see if a patient has COPD positive or negative. You see that the performance so for each patient, I have data taken across these 7 places. So the data that has only the data that is taken from each position, I had created separate models. So the posterior right, you see that there is a good performance compared to others that has been across precision recall and FN score. Now, this again, clinically speaking, like I said, it could be hard to understand. But using machine learning, I try to see because this was inspired by Sundar Pichai's Sir's talk, Google, the CEO, where they did a study on with Arvind Eye Hospital, considering the eye and different analysis done. So he did talk that there were other parameters that we were able to look into, like the age, gender, and so many other information could be retrieved from the eye itself, something that the doctor did not expect. So I think that kind of triggered this kind of an study, because most of the studies that was done, there was no foundational data given as to what was taken from what data was considered to do the research, what pre-processing was done to actually compare my results. So this study was tried out, and it did show that one position actually has a superior point. And looking at it, in further studies that had come, something that validated the study was one database that was launched later, a research lab from Taiwan. They said that we are not taking data from the anterior portion anymore because the heart is in front. More noise is coming in this area. It is much more harder for us to get lung sounds. So we are focusing on the posterior side, and the database was taken totally from the posterior and the lateral side. So I think there is a trend that we see that this study will help with market adaptation. If you can build a really good product, but the user cannot user has a huge learning curve to actually understand how the product can be used. If he has to look at sites and is going to struggle using that, he needs something that is very, very simple, something that is very easily understandable, something that it can interpret and give it on his mobile phone, for example. Only then the market is going to adapt. If the learning curve is high, even if you do extremely good research and extremely good results, the market is not going to take it, and there is no point having that kind of a research. I think we can skip some of this. But just to show that agentic AI can be used. So you can build different agents like this. Langflow is one platform which gives you a visual representation. Faculty working in this particular area or trying to move into this particular area, Langflow can be a good place to start. You can make use of it and try and build this particular application. So if you look at my the project that I've done, there are areas where I have to take out spectrogram, I have to remove noise. There are multiple areas of work. I can have multiple agents to do that work, right? So looking at generative AI, like I said, interpretability, I think will be the first most important advantage. Second is going to be data augmentation. I do have some skepticism there. I'll talk about it in my conclusion. And chatbots. So a patient can feel more comfortable having that kind of a system where medical queries can be addressed. Agentic AI, like I said, you break down your research problem statement into multiple areas, have multiple agents do it, and call them from a central point. And so that study is done. Yeah, one agent can actually even look into research papers that are there outside. So I'll skip the other 2 applications. One study that I have done with Amrita in a speech pathology study that we have done in detail for a condition called dysarthria. Just to highlight one parameter, this is a very rare case. To be honest, I think we did not move further so much in this particular area because across the 1 year that we started collecting data, we had like some like 40, 50 patients in total across 8 or 9 classes. So when you have data like that, because machine learning models are totally data driven, we cannot proceed with this kind of it is very hard to make use of AI directly. Just to say that every research can make use of AI. And when the data is too scarce, going for data augmentation techniques and generative AI data can be arguable. I wouldn't say that yes or no, but it could be arguable. So I'll skip through all this. These are results that I've seen. And the heart acoustics, so the Cambridge University has an acoustics lab which is doing the study. So I'll skip that 2 case studies. I'll come to my conclusive points. I think certain limitations that I believe each faculty will be facing here. One is, like I said, when you look at healthcare applications, the entire model, machine learning model, deep learning model, transformers, the entire AI depends on data, right? So you have good algorithms, you have good processing computing capabilities. It's like the brain, but without data, it is going to fail. And so everyone working on medical data knows this. And so sometimes what happens is, like even this lung study that I did, I had seen implementation of people from other areas, especially in the consultancy area that I've been working, where you see that you go for data augmentation technique where you flip the image, you rotate the image, right? You add noise to it, that is fine. You scale it, you change the pitch of it. You cannot do so much to medical data like that. Once you flip, there's an inspiratory and an expiratory cycle to it, how the data goes across time. You cannot just flip that data. So it works for cats and dogs when you want to classify them or different animals, where especially the information is spread out. But a clinical signal will have a structure to it, and so that has to be kept in mind while data augmentation is done and while generative AI is used for building huge amounts of data. So that has to be a little care should be taken there, and studies could be done, right? So your database could be biased based on demography, uh, based on language. There are other areas which maybe we do not have to get into so much now. So, like I said, explainability will be one area where I think all this advancement in AI will actually help a lot. So that has been a huge obstacle for a long time, and I think that is why even doctors, struggle to work along with us, right? So once these model can explain themselves, you can write out a patient report, a summary from what your model sees, or it can actually even make a simple summary for a layman to understand. This kind of helps a doctor a lot, and I think this will enhance a lot of things. So this is almost my last slide, so I'll close with this. So like I said, all this is true up till Jan 7th. And since there have been a lot of these disruptions, and DeepSeek is one of them. So obviously, all of us have heard about it. Um, I think where this drives towards, there are multiple areas to this. One is obviously the geopolitical side of it. How many of the Western countries is not going to let, like, data is a new oil, right? So who is going to have access to all the data? That is going to be the person who is going to lead the world, have power, over the next many years. So China has done extremely good work. They have built very cheaper models that are trained on a much lower cost, and they made it open access, right? So keeping the politics aside, possibly now, if you look at Sam Altman had come to India, he's trying to have more tie-ups and try and see that more products are used in our research facilities. Possibly that might happen now. Modi is also in talks with Trump, so a lot of that kind of drives how research might go on. But as independent researchers and faculties that we're doing, you can see that this technology is coming more towards us. Uh, Focusing on the theme on wearable technologies, I didn't go much into products much, but having a much more cheaper uh, uh, a cheaper option, in the sense like to have processing done on a small device itself. It kind of lowers the cost. It brings in a lot of functionality. There's a lot more work that can be done and make these products possible. So I think a lot of faculty in ECE can focus on different embedded technologies that have been used. More high-end models can make use of these models, and implementation can be done. Wearable technologies, we find a lot of application, and all this technology is coming towards us. That is the reality. Keeping all the politics and the negatives aside, all these technologies is coming towards us, and they can be implemented in our areas of research and case studies as well. Thank you so much for patiently waiting. I'm so sorry for taking extra time today. But thank you so much for the opportunity. If there is any questions, I would like to take it.
Dear participants, if you have any queries, please ask Dr. Johnson. So there is a question in the chat box, sir, from Nitya Kulkarni.
Okay. Are there any open source GPUs that can be used for deep learning implementation, similar to Google Colab? The Google Colab is one excellent platform that we can use. So I've used most of my research. I've done it in that as well. Looking at all the models, um
Yes, sir. Yes, it is audible.
sorry. Yes, no, I do think that Google Colab is one place where researchers like us can work. I think looking at other platforms at this point, maybe I'll look into it and I'll try and get back. Um, there is there are a lot of models that are coming up which are open sources now, but I have not personally done deep learning studies on it for me to actually give you a direct answer. But maybe I can get back on it.
Any other queries? If you have any other, if you have any other queries, please ask sir, or otherwise, please note down his contact details so that you can able to contact him. There is another question.
Most widely used data augmentation technique, I would say that depends on the data, but again, not to give a general answer like that. I think you can go for some level of noise addition to it. That is not because of biosignal, the frequency components have huge clinical significance. So adding a little noise to the signal can, to some extent, because you do expect your hardware to give some level of noise. So something like a Gaussian noise or other noises can be added to a little extent. See, the way of looking at it is if you were to take your product that you have built and you were to pitch it to a doctor, and you tell a doctor that, and the doctor is going to ask you where you have taken the data from, right? So you can say that I have taken all this data from KMCH or I've taken from other hospitals, from Apollo, I've collected this data. And then what techniques can you justify to a doctor is the answer to your question. So you can add some level of noise, you can say, but if you say that you're going to flip or rotate and go for so many other techniques which a doctor might not agree or might not be able to relate, those techniques will not be at place.
Any other questions? If there is no queries, we can just wind up the session with a welcome note. On behalf of Aditya Institute of Technology and Department of ECE, I sincerely thank Dr. John sir for his enlightening session on transforming healthcare through wearable technologies and AI. And the concepts and the insights into the AI-driven healthcare solutions and the research that you have done over the wearable healthcare technologies have provided us with a deeper understanding and it creates an impact on modern medicines also, sir. A special thanks to Dr. John sir for his valuable time and expertise, and thanks for the wonderful presentation, sir.
Thank you, ma'am, for inviting. Thank you for all
Thank you so
the
much.
faculty for patient listening. I would be happy to connect with any faculty. You can write me a text or connect with me through LinkedIn. Thank
It's
you.
a pleasure to, sir. Thank you so much, sir. Thank you.
Thank you, ma'am.
Dear participants, we have to start the next session within 5 minutes because our next session will be at 5:30 p.m. Please stay tuned. And there is another information which we wanted to provide, and yes, the session link, feedback link will be provided very soon. And the final assessment link will be on your ATAL FDP. You have to log into your ATAL FDP and you have to attend your assessment through ATAL FDP. We will not be posting any link of assessment in the WhatsApp group. Okay, so please make sure it will be activating on at the time of 7. It is an automatic activation from the ATAL portal. So please, be very keen on attending that test at 7 p.m. And it is an 1 hour test, and we have given 25 questions as an objective type question. It's all very basic questions, which is very relevant to the FDP sessions which we conducted in the last 6 days. Okay, so please be login to the ATAL FDP by 7 o'clock and for the assessment. And the session 2 and session 3 feedback links will be posted after the session will end. Thank you.
Hello, ma'am. Hello, ma'am.
Yes, ma'am.
Ma'am, yesterday also I did not receive the feedback link in the chat box, ma'am, because of network issue. I'm not able to just get back, ma'am.
Okay, okay.
Yesterday, 2 session also I'm not giving the feedback.
It were closed. There is no possibility of attending the feedback form now, ma'am. It is okay,
Okay.
ma'am. You can just give me a text through your WhatsApp number.
Yesterday also I'll send a message to you, ma'am. This is Reshma from Sona College, ma'am.
Okay, I'll check it out. I'll check it out.
Thank you so much, ma'am. மேல போயா சீக்கிரம் போய் பாத்துட்டு ஓடு.
ரோல் போட்டுருக்காங்களா? சரி, ரொம்ப
Ma'am, can we start?
Sir, yes, sir, we can start.
Yes, good evening, ma'am. So good evening, everyone. Okay. So then today, so we are going to see something so related to remote patient monitoring and virtual care. So remote patient monitoring is like how we can monitor the patient remotely or virtually. That is what today's topic. So also I'm going to share a few things related to neuro, so rehabilitation, also like wearable technology, how we are monitoring remotely the patient. The area that I'm going to cover now. So let me share the screen. Please wait. So if screen is visible, please confirm. Yes, the screen is visible.
Yes, sir, yes.
Yes, thank you, ma'am. Thank you. So like, so that is what like remote or structural health monitoring using wearable sensors. Like we can use many sensors like if for a patient, so for monitoring that we can use smart glasses, smart watch, smart shirt, and then GPRS and GPS control, and Bluetooth key trackers, smart shoes, and smart socks, pants, belt, ring, finger, right place. So as of now that so earlier what we are doing in the sense like we will connect the sensor, we will connect the patient with all the accessories or sensor or something, and we will monitor the patient remotely. So we will test, we will send all the data to cloud, or we will recover the data from the cloud and we'll do it. But as of now, wearable technology, like this FDP idea is very good title, like wearable technologies. Wearable technology is going different level. So for example, earlier, so for timing, so we will use watch, but nowadays we are not using watch, smart watch, smart band. Or if you want to check your pulse rate, you want to use pulse oximeter. Right now, your smart watch is measuring how many times you are walking, running, and all. You want to use timer or something. So for sports people, if they want to know like how much time they're taking to complete a one relay or one circle of athletics, so those kind of things, and same smartwatch they can use it. So at the same time, smartwatch applications are more smart glasses. So for AR, VR, virtual reality. So I told you know one company. Maybe I can show you that company name. So Mind Lab. So it's called Mind Lab. So intelligent customer insights. Just wait, I will check. So whether this is a. So I think it's not. See, like just wait. So this company usually you see like Mind Lab. So this company is the very expert company. So they're what they're doing is no like what are the patient. So what are the patients are coming up when you're coming to that consultation. This company is coming up with different ideology. Like they are showing everything virtually. What is happening inside their body, inside their brain. So then everything they're showing it as a as an like virtual reality. Virtual reality is nothing but, so just wait. I think they have not updated properly. Okay, no problem. So like this is what like Mind Lab is the company. Like this, various companies are there. Right now, when we are going to see hospital and the consultation, doctor is telling, so you are affected with so arthritis or heart attack or cancer, tumor or plantar fasciitis. Like this, then we have so many problems. But as of now, doctor is telling orally. So if doctor is telling something okay, normal or something, then we are getting afraid. Like, so this is a problem, or there is a problem, big problem, or we are going to lose our lives and die like this, and we are facing a lot of struggles. Same way, like right now, if you're visiting doctor, what they are doing, simply in computer, they are putting up, photos. They are saving some photos. So whenever you are asking, so what kind of problem you have, so they are not telling orally, they are simply showing the image. So this is kind of problem only you have. Sometimes they are showing videos. So this is a problem we have right now. So whenever you are there, or maybe like anytime, so like these are the problem. These kind of treatment only they're going to apply. Likewise, doctors giving some suggestions, isn't it? The same way, like virtual reality or virtual health monitoring, like so if you are putting a smart glasses, that glasses can monitor completely your all the data. That particular glass can monitor your the data in the sense what is happening inside work. Same virtual reality as a videos or maybe like as image, or when layer by layer technique, then we are having the discuss smart glasses, smart watch, as you know, like it is going in different level. Smart shirt, so patient parameter or monitoring, or like temperature monitoring, all sweating or maybe like temperature monitoring, everything, then we are monitoring by using smart shirt. gprs is available in each and every area. Bluetooth key tracker, it is all these kind of things are coming under this picture. So it is started in 80s, not now. So this virtual or telemedicine thing started in 80s. On history of wearable technology, you see like in 1644, 1762, 1961, 1977, like this, and the history of wearable technology is huge. So we are simply going in another level. That is what history. So and then wearable technology devices release date and timeline. You see like we are coming with different brand, Fitbit, New Car, Jawbone, and then Sony, Samsung. Like this, there are a lot of things are available. And then, so where that wearable technology is used, or what is wearable technology? That is one kind of a thing. So where it is used means, or what is wearable means, like as of now in medical, so we are using to monitor complete patient parameters. Like you see, like glucose level, we can monitor activity, calories, weight, medication, nutrients. You know, like one more thing. So as of now, so before 5 years, so we were telling like, so almost all the people are using mobile phone. So the people are not there. Even no one is available without using mobile phone. That is one time. Even old people, grandpas, grandmas, all are using mobile phone. But right now, so that is the case right now, earlier. But right now, so people are using mobile phone less than 5 hours, very less. People are using mobile phone less than 5 hours. Each and every people are using more than 5 hours. Or even students or other people, so they're using more than 8 hours out of 24 hours. So because we are completely depending for more calling, or maybe sending messages, or seeing videos, or Instagram, or reels, or YouTube videos, and even bankings, share market, and then all approvals, and then meetings, office meetings, and everything is happening in mobile phone. So that is what, like even recently I was meeting that IIT professor, or Upper IIT professor. He was telling, in future, don't go with PC based application. So faculty, since it is a faculty program, so I can suggest you in future. So don't go. As of now, you see like how many people are using laptop. So maybe morning, if you're going to office, so if you are working in banking sector or something, then maybe like almost for 4 to 5 hours only we will use this laptop. Apart from this, everywhere that we are using this mobile phone. That is the case right now. So then, in case if you are trying to develop any product or anything so related to this thing, so then you want to come up with so this thing like, so mobile phone. All the things should be developed in terms of mobile phone. So this here you can see glucose level, activity, calories, weight, medication, nutrition, everything you can monitor by using this thing. So there are multiple technologies are available. So So you can use like Bluetooth technology or Wi-Fi technology, or maybe like wired technology, Wi-Fi technology, or maybe like any kind of a things. Like as of now, Bluetooth is outdated. We are going completely towards so this Wi-Fi technology. At the same time, you see the market growth in 2022. Last before 3 years, you see like almost it is almost 1,105. So market to millions, $1,105 million US dollars the market growth. It's a functionality of this wearable. So there are multiple variables are available: near body, on body, and in body electron. Likewise, we have so many things right now. So near body, on body, and so likewise, then near body means near to the patient body. If you are taking the sensor, then to measure. On body, on patient, you want to connect the sensor. In body, you can keep it inside patient. Electronic textile, so we can connect something. Electronically you can connect, and you can either it's electronic. Classification of wearable technology: watches, basic watches, smart watches, fitness trackers, and hearables and all. Classification: watches separate thing, fitness trackers separate thing, and hearables is separate thing. And then classification of wearable technology: smart clothing, smart jewelry, and head mounted displays. Everything is a different thing. Just wait. Sorry. So smart clothing, smart jewelry. So even you can place the sensor in bracelet, necklace, and the brooches, rings, analog watches, and fitness jewelry. Also head-mounted displays like augmented reality, virtual reality, like this, and there also you can use. So and then you can see glasses, wearable cameras, and body sensors. So there also you can use this kind of a technology. So then you can see implantable wearables and exoskeleton, location tracker, visual purpose. So these all the areas. So you can take. These are the places, or these are the classification. So you can simply take the data. So implantable wearables is so we have seen in the movie, Taniyar movies and all that. You can place the trackers inside the patient body. Exoskeleton, that is also one kind of wearable. It can take patient how the patient is moving, or all these things can be monitored. That is also one kind of technology. Like this, and we have so many technologies are available. And then basic watches, different. This is called watches. Just wait. I think something. I don't know why it is showing. Okay, so like smart jewelry. So then glasses, wearable cameras, and body sensors implantable. So these watches, as you know, like everything is happening in the watches. So everything happening in the watches means, and whenever you are connecting, whenever you're placing watches, it is battery operated device, and we are tracking, and it can be used for luxury purpose, also like athletic, or maybe like fashion watches, and then kids watches like this. Then we can use it for all purpose. As of now, this thing we are using only to monitor the patient data. Also fitness tracker, it's not for the same time it can show you the timing. At the same time it can be used for calorie consumption, run, heart rate, and quality of sleep, and all the purpose it can be used. And then earbuds, hearables, smart shoes. So inside the shoes, then you can place the sensor, and inside the shoes you can place the sensor, and you can monitor the patient pressure and all such things. Maybe I can show you one thing. One company called Novelty. So then I want to show you that one. Novel. Okay, novel.d, I think so. So that is there. I can show you like this is what the product pressure measurement system. So you see like, so when you're walking, so this can take all the data. Like when you're walking, so this can tell you all the data. So like you see, so like all the data can take. That is one kind of thing. Also, when you're walking on the pad, so it can take like where your pressure is high, where your pressure is low, and then on what position you are, on what gait axis, then you are walking. Everything you can take. That is what gait. So all small and large patterns are available. So for diabetic foot care, orthopedic diagnosis, also sports medicine, post-surgery assessment after surgery. So like maybe after replacing the knee or hip also that time also we can monitor. Pediatric diagnosis, maybe like walking position is wrong, particular people that also can be monitored. So rheumatology conditions, neurological disorder, elderly foot care, custom orthotic design and everything, then you can simply monitor. So that is one kind of product. The same way like this one, the food pressure monitoring is wearable. So one research saying that so based on the food pressure, simply you can monitor the what kind of organ is getting failed. Also diabetic levels we can simply monitor. This is called inside footwear. Simply you can test sensor. The data you can get like this. When he is walking, how the walking pattern is getting increased, decreased. Also you can see. So application, research, diabetic foot care, orthopedic, same post-surgical, prosthetic, pediatric assessment, kidney analysis, soft free gait, everything you can see. This is what one kind of sensor. Likewise, mostly these things are for pedal measurement, like how they are moving, bending, and everything. Also, like when you are holding, if you want to know your hand pressure, how you are holding, where the pressure is getting increased, which finger. So everything you can see by using this thing. That is also like available. Likewise, this is one kind of a good research. Just wait. Sorry, guys, just give me 10-second time. Okay, so this is called where you are giving load when you are walking with help of walking stick. So at what time? So at what time you can stop using this? Walking stick. Everything you can measure. Buttons and how you are pressing button, how many times you are pressing buttons, everything you can simply use. So it sense how you are sleeping also, the sleeping position where you are sleeping also you can simply monitor like. So these kind of wearables is going in different level. So this company is doing very good. So let's do it. That is what your smart shoes. The next is called glasses. As you know, like when Meta is arrived, like so we have started using each and everything with the help of glasses. So Google Glass, smart glass like that. Smart jewelry, inside jewelry, we can start placing our data monitoring and other things. It's called smart jewelry. And even in bracelet, necklace, and brooches, rings, and analog. So in all the areas you can place this thing. So that is also available. So next is called wearable cameras. So by using the cameras, if you want something monitor the patient data or how they're speaking, mainly artisan people. So all these people, so we can simply monitor the data by using the wearable cameras. This is going another level. In some cases, it's not legal, but most of the places. So just wait. So then, if you want to know how the people are reacting, there you can use this technology. So and then body sensors, you can place. So you can place this. You can edge this sensor into the patient body. So that you can sweat monitoring, or maybe like even skin cancer. So those all the things EEG, ECG. So those kind of things also can be tracked by using this thing. So and then location tracker. So location of the particular device can be tracked. This is already available in iPad or AirPad or mobile iPhones, or maybe even right now we are started using in two-wheelers, and four-wheelers, and all the areas that we are using the location trackers. And then head-mounted displays. This is for AR, VR, so virtual reality. So as I mentioned already, exoskeleton. So this exoskeleton can be used for it's one kind of wearable. So it can support the patient. Also, it can used for mobility. If mobility is not good, so we can materialize this mobility by using this kind of exoskeleton. And then gesture control wearables, like simply if you're placing the pads, I mean the bands, when patient is moving when patient is moving their hand, so simply like based on the muscle activity, so we can take all the data. That is called gesture control wearables. And implantable wearable. This is also one kind of implantable. So blood sugar level for diabetics, you can simply monitor the blood sugar level. That is also possible. Also, like objective of this thing, objective of going for this kind of wearable using virtual is nothing but improved patient care and productivity, effectiveness, appropriateness, and then efficiency, quality, so and then safety, privacy, and confidentiality. Sorry, improved patient care. Each and every technology we are using to improve the patient care productivity. For example, so if you want to monitor at a time, if you want to monitor 100 patients, so each one by one we cannot monitor. It's very difficult to monitor. So you can place these kind of devices. You can place these kind of devices to the patient on all 100 numbers or 200 numbers. All these patient data at a time you can monitor. That is called productivity. Effectiveness also can be increased. So quality of service also can be improved. So and then the next is called the who are all the people are using this technology. So payers, providers, manufacturers use easy, like payers means they are the fund providers. Right now, Centene, Humana, Kaiser, and then Bright, and then Oscar. These kind of people are very important people. There you can see private occupants, insurance startups, and then employers, and then employee benefit. As of 2018 global system, this is government providers. You see, like providers means hospital people, hospital like Cleveland Clinic, John Hopkins, or Walgreens, or Geisinger. So these are the people are providing. So this support. And manufacturers are the one they can manufacture the device. Manufacturers are the one they can manufacture the device. That is called this thing is earlier were like and then Apple, Fitbit is very important company in the world. So also distributors. Distributors is nothing but Amazon or maybe Flipkart or maybe like Cardinal Health. These by using these people, then you can simply distribute. So the payers are the fund provider, and then providing like where and all we can provide is means hospital where and all we can support, and manufacturer who is manufacturing the device, and distributor. So you simply distributing the you simply distributing the particular product in the online or offline. So that is called the different story. So where and all you can use physical activity interaction monitoring, and then mental status monitoring, sports medicine, and then weight control monitoring, public education, patient with stroke. So nowadays you can see like patient with stroke is very important thing, because stroke is nothing but if there is any blood circulation getting failed in between the heart to brain is called stroke. If we are facing that one, so then we may lost our consciousness also. Like it is a big problem for us, like within short span of time we may lose all kind of consciousness also. Within 4 hours we want to put an injection, anticoagulant injection. If you are failing to put within 4 hours, so it's, I mean, chance of recovery is very very less. Maybe maybe we can tell it's zero. So like, so in that area, paralyzed, so to avoid this kind of paralyze, so what are the different kind of variables you can provide for the particular patient? So that is called very major impact on that patient stroke. Weight control monitoring, already we started using the smartwatch. Based on that one, it can count step count and each and everything. So patient with spinal and brain injuries, spinal cord injuries. So for that one, you can use exoskeleton. And then chronic pulmonary patients like heart or lung failure patients or asthma, TB patients also you can go with wearables. I mean, how they are coughing or how they are doing, like, I mean, other kind of everything you can check by using this pulmonary patients. Heart disorders, even nowadays, even smartwatch can help you to detect heart failures. That is also available. Blood disorders, diabetes care management, Parkinson disease, autism, depression. So even some of the smartwatches right now it is telling stress level of the patient. That is also available. So these all the things are happening right now. So 11 companies using wearable technology in healthcare. In healthcare, if you're coming to healthcare, so so they are concentrating on fertility, pregnancy, and overall health. And then gym watch, gym, cardio mobile, ECG diagnosis and treatment, motive to monitor activity, sleep, and heart rate. And so Apple Watch and Fitbit, Garmin, MySkin Track, Owlet, and Temptrack. Most of the companies are from US because they are completely into so these kind of wearables. So that is what like 11 companies using wearables. Maybe I can show you like few other things. So if you want to have some research idea, since you are from faculty background, so since you are involved in so many research activities, if you want some ideas, so maybe for getting funding from DST or somewhere, so you can use this portal for getting idea, wearabletechnologies.com. So there you can see. So one by one, you can see idea. There are a lot of ideas will be there. Also, like you can see innovation of the month. So innovation of the month till February. This this portal is maintained from Germany. So you can see innovations. You can go to all the things like boots that relieve leg pain. If you are simply placing this kind of a thing, it can relieve all the pains. It's a good product. Because nowadays leg pain people, I mean the people who are without leg pain is very less. So for those people, you can use also like Apple bringing back the e-paper smartwatches. And so Samsung unveils SR headset and the world's smallest surgical robot. So likewise, revolutioning women's health that is also available. So likewise, you can see like maybe we can go with innovation of the month. So you can see like this is called revolutioning women's health. So simply you can place this. I think so. Like so simply you can place this kind of a. Just wait. Just wait. I think something happened. Okay, no problem. So hope the screen is visible, right?
Sir, yes, sir, yes.
Yes. So okay, this you can see like this kind of a so neuroscience and a non-invasive drug-free solution for women health. So that you can see like drug-free solution for women health. The people if you are any we are till to spotlight little groundbreaking wearable device that is transforming women's health developed by Sampair. So for what purpose we are using everything, you can see it over here. Likewise, if you want any idea, innovation of the month, any idea. So here you can see remote health. As our topic is remote health with smart patches. If you are placing small sensors like this, it can monitor all the things. It is right it started used by Siemens and then Epoch system. So everything they are started using it. So likewise, remote ECG. Also one more thing is there in hospital patches. So in hospital, like so simply if you're monitoring small patches, then it can monitor completely whether the patient is okay or maybe not okay, or whether he's coming under the fallen risk. That also can be monitored. That also I can show you. So and then fight against voice disorder. So what kind of voice disorder they are facing, that also can monitor by using this thing. So likewise, if whenever you want to have some idea, then you can take it from here. So also I have seen one more thing. So I can show you that it's right. Hydrogen gel. It's like maybe it is not coming under innovation of the month. So I want to show you one more thing. So these all the ideas are available. Whenever you want, you can take it. Hydration monitor. So patient hydration level monitoring also you can do it. So hydration level monitor. So mood swings also can predict. So smart wearables, like you can see, like this is recently it is trending over the each and every places. This is one kind of a smart ring. So smart ring, so that can monitor the patient complete activity. So like how it is developed in India. So how much stress they are having, or maybe like all other parameters it can monitor, like how much time they're sleeping. So fitness trackers like offer all the purpose. Then you can use the device. And one more device I want to show you. So smart ring. So this is called new smart ring. So and one more thing, if you are using this thing, no, like you can simply replace a PC keyboard. That is also I want to show you. That is what I want. I'm tracking. Smart robot. You see like this one. So next comes to like how you are doing exercise, like your diabetic level and everything. You can monitor by using this thing. And then extra food. Just wait. Robots. So vocal disorder. So they are here. This is what the AI technology, G healthcare and Mediview launch AI radiology shoot. Like if you want to know like where the problems are, problems there like any kind of like what I can tell you like tumor or maybe like there any ablation problems. So there you can see like by using that the AR method, like simply if you're putting a glass, then there you can see like how it is available. Also voice disorder, also like BP, only for BP you don't want to place a cuff, you don't want to place a cuff, small band you can place, that band can monitor complete activity of your BP. That is also available. So then it is coming to a normal page. Sorry. Still I want to show you a few things. So that is what this thing, vocal disorder. Also like you can see like extra, so smart trying to boost hero hopes. And then one more thing I want to tell you, like it's called like extra thumb to boost productivity. So we are having one more thumb like this. So what this can do is this can simply increase your productivity. Simply, I mean, for example, if you want to hold this two orange at a time, by using this finger also you can hold. By using this fingers also you can hold. Hold. That is also available right now. So then, so you can see next. I want to show you one interesting technology we have so far. So like here also you can see virtual reality. Right now here also we are using like in operation training. So how to give a training to the people there also we are using. So and then we see wearable bra could detect breast cancer area. Breast cancer, for detecting breast cancer also we are using separate device. So likewise then we have so many applications for this wearable. Anytime if you have time then you can take all the ideas from this portal, so you can take ideas. So then one more thing. So you see like scientists control robot with Apple Vision Pro. By using Apple Vision Pro, simply they can control. So that thing. So then pulse oximeter also they are having the patent rights. So one more thing. One more thing I want to show you, that is how that small things, I mean, small ring is replacing patient, I mean, or complete, so how we can tell, complete keyboard. I mean, in our mouse pad we are using, no, like touchpad, mouse pad, or in our laptop. If you are wearing small ring, that can replace complete mouse pad. It is going to happen in future. Also, our Apple is having one more pattern. So, if you are placing your AirPod inside your ear, it can measure or can monitor your EEG level. It can monitor your EEG level also. That is also it's patented. So maybe it will come in future. I mean, within short span of time, it will come to the market. So this is called monitor health by listening to the body sound. Body, if you are having any kind of a sound, then this can be used for so measuring that one. So that is also available. So next. So these all the things are variables. But I know somewhere I missed that one. I don't know. So likewise, you can see so many applications are here for socks, smart socks. So can keep dementia under control. So this kind of things were controlled dementia. So likewise, you can see home wearable pain management system. So likewise, like whenever you have time for wearable, like you can use this portal. Okay. I think somewhere I missed that thing. We will see here whether it is available or not. These things are called each and every month how they are scale-ups. So you can see small ring. This was developed in the year of 2022. Small ring that can detect continuous heart rate monitoring. Also, atrial fibrillation can sense with 99.6% of accuracy and real-time measurement analysis and remote data access from your doctor. Simplicity and easy of use likewise, then we can use this thing. So even this smart ring is playing too much of things. So likewise, you can see. For the visual impaired people, so if you are simply placing a camera and then all the chips inside, this camera can tell the people like what is coming in front. So by using that, object detection, object classification. So it's completely AI guided. So it was developed in the year of 2020. So this camera can sense completely what is happening or what is coming in front of the people. Next, what else? This is for neuroscience. So this is for neuroscience. So if you're placing this kind of a headset, so this can detect or we can ask patient to meditate or it can completely sense what are the different kind of problems that we have. Same like this, we have one more thing is called Muse head sensing band. So Muse head sensing band, you can see like this is also one kind of a thing. So if you are simply placing, it can measure EEG. So you can see like it can measure EEG the same time. So it can so EEG also like gyro and the axle like how you are moving, how your body is moving. Same way like it is monitor respiration. So then it is simply calculating focus and relaxation, how the people are getting focused or not focused. So these things also then you can take raw data. So cost of this product is almost you can see 249 USD. Muse S is almost like 400 USD. So these kind of devices also available. So there are a lot of wearable technology and remote monitoring things are available. So this thing you can monitor from anywhere. All the data will be so monitoring the app. Also then you can move it to so OneDrive or maybe iCloud or maybe Dropbox. So each and every area that we can take the data. So that is what neuroscience. Okay, next. So what else? V motion. So the complete patient bed can monitor. So complete patient bed can monitor your patient weight. So you do not use separate weighing scale for the people who are sleeping inside or sleeping on the bed. So that is also available. So next. So this you can see that this you can see like it is very important thing. So if whenever you want to take EEG, so this is already into the market. So already into the market, so like, this is like a normal form. So this is the electrode sensing. So if you're placing small things over here, it can sense all the data and we can get the EEG data. So then mainly that it can be used for so monitoring that it's a complete electrode, same like ECG electrode, then it can be used as a EEG electrode. So this one recently we get purchased and we get checked, then it is working well. So likewise, then we have so many application. The same way, like I want to show you something related to your neuro. So faculties. So anytime we have time, we can use this website. You can take multiple ideas. For example, this one boot that relieve leg pain and discomfort. Simply, if you are putting inside, like we are placing as both sides, like we are placing, the control module. I think it is giving pressure inside. So normally air pressure. So and then positive, negative pressure. Then it is relieving the patient leg pain. Also, I think they are applying some hot air inside, so the patient will feel more comfort when they started using this thing. That is what the thing. So likewise, you can take so many ideas over here. So same way, I want to show you something related to so neuro. So neuro rehabilitation, that is also very, very important. So neuro rehabilitation is nothing but neuro rehabilitation is stroke. The people who are affected, this is also one kind of variable. Then we want to monitor the patient continuously. So if people are affected with brain failure or something, so they will lose consciousness. Also, their coordinates will be missed. So they cannot do normal activity. Like even if you are asking them to hold water bottle or some piece of glass water, they cannot hold it. That is a big problem. You see, like introduction, you can see like, so they cannot work independently, even for eating or maybe standing or sitting. So they cannot do it independently. The people who are having, so that these kind of discomfort, also like such the people who took surgery, that is also, so they cannot, stroke patients or medicated patients or surgery patients or lifestyle modification, everything we want to do it. So when this is what ischemic condition. So ischemia is nothing but that blood. There are two kind of a thing. One is called ischemic, another is hemorrhage. Hemorrhage means it's called leakage. The blood is coming out of the blood vessel. Ischemic is nothing but inside the blood vessel. I mean that cholesterol getting formed inside. So because of that one, so we are not getting the particular thing that is called ischemic stroke. Second is called hemorrhage. So there are two. That is what first is called ischemic, and one more thing is also available. That's called TAA. That's a mini stroke. Ischemia is nothing but blockage, and then hemorrhage is nothing but it's called rupture. So the blood will come out. There are two kind of stroke. So ischemic we can cure by using anticoagulant, but hemorrhage is very difficult. So you want to do brain surgery. So effect, they will lose their movement and sensation. So they will forget their language, and then how to speak, and eating and swallowing, like they cannot do it. The vision so won't be proper, and cognitive thinking, reasoning, judgment, and memory, everything will be lost, and perception and orientation will be lost, and orientation to surroundings. When you are asking them to walk or run, or everything will be lost. Self-care ability, bowel and bladder control, they cannot control their urine. So that when the bowl is getting full or bladder is getting, that also cannot be monitored. Emotional control, sexual ability, everything will be lost. That is called effect of stroke. So what is the purpose of rehabilitation by using this wearable and so remote monitoring? That is called improving the mobility and strength, improving the patient mobility and strength. That is what the first thing. And then improving the speech and language skills. Then we should improve their speech. So then we want to give speech therapies, and again we want to recover their languages and cognitive function. They should think. So standalone, they should think. That is also is very important. Managing emotional and psychological changes. So mainly we should manage their emotional and psychological changes. That is very important. So that is also for that also we are using that rehabilitation, and so also educating patients and the caregivers about stroke prevention and management. So that is also very important. We should educate the people. And then rehabilitation after stroke. So you want to do like you want to do, or you want to ask them to do this kind of activities, and also like physical therapy. So you want to ask them to lift weights. Also, like you can ask them to hold so small weight, 1 kg or half kg. So again, that same coordination we want to take it back. So how their coordinations are coming. So it involves like coordination, balance, and strength. Regaining the strength. So only for stroke patients. So also like it can also to improve cardiovascular activity for the particular stroke people. That is very important. And types of physical therapy, so range of motion. Range of motion means how much range they can take this exercise, and strengthening exercise, strengthening the muscles and all the stuff, and then balance and coordination exercise. So we will ask them to stand in single leg or double leg for sometimes. So balance and coordination exercises, and gait training. So and then assistive device training. So these all the things are available. Benefits: mobility can improve, strength and endurance, coordination, risk of fall. So they will not fall. And then greater independence. And then finally they started to move like independently. So like that is what our main thing. And then types of speech therapy techniques you can see. So articulation therapy, and then language therapy, and then cognitive therapy. Articulation therapy means then, so we want to tell them like how they are speaking. And the language therapy, then you want to give different kind of language, Tamil or French or maybe like English their own native language or mother tongues. Likewise, if we want to give up a different thing. Cognitive therapy, then we want to ask them to think. They should think. That is what cognitive therapy. So that is also there. So and then speech therapy for stroke rehabilitation. That is like even for Parkinson people, they cannot able to speak because their neck muscles will be so tight that they cannot speak properly. So speech therapy is very important for stroke management or rehabilitation. So we want to ask them to we should ask them to speak more, and we should come up with different things. It's called speech therapy. So then occupation therapy, then playing. So playing and then dressing, eating, bathing, daily living skills. So how they lived the same kind of living skills, and we want to repeat it once again. All of a sudden, their normal activity, everything will come to the picture. That is what occupational therapy. So then next is called cognitive therapy. That is called, like as I mentioned earlier, it's called thoughts, feelings, and behavior. That is also one kind of very important thing. So the next, so rehabilitation equipment. So you want to ask them to hold parallel bars, treadmills. You want to ask them to walk. So with treadmill slowly, we should ask. And then stationary bike, hand weights, resistance bands. So all such things they should do it. That is what. So that is what rehabilitation equipments: parallel bar, treadmill, stationary bike. So like hand weights and then resistance bands. So these all the things are very important. So then just wait. Sorry. Also resistance bands is nothing but it can when they are it's elastic bands. So when if you want to improve their mobility or something, then we can use this resistance bands. It simply can so hold and can fetch it into some kind of area. So that way, like we can simply ask them to improve their muscle activity, also slowly like can so recover them. So that is one kind of area. And then preventing future strokes. Also, like when you are doing these kind of activities, also this can prevent the people from the future strokes. Also, then we can ask them to change lifestyle. So quitting smoking. Also, like diet and exercise they want to follow, and alcohol consumption they want to completely avoid, and managing stress level through a relaxation technique or therapy. That is also then it helps them to prevent. Also, like we should not ask them to take any medicine apart from prescribed level. Also, then sleeping pills they should not take, or antiplatelet medication to prevent blood clots. So blood clots, if any blood is getting clotted, so then again and again, then we want to ask them to take anticoagulant and antiplatelet therapy. So high blood pressure they want to control. So those kind of tablets also we want to provide. Group therapy is nothing but we want to ask them to sit along with a group of people or group of friends or group of normal public areas, and we can ask them to regain their psychological support. So feel less, so then they can smile and they can interact, they can get to know about a lot of things. That is called group therapy, also very important for this remote and rehabilitation technique. Individual counseling, so by taking individual counseling also, etc., it can be taken remotely or maybe like virtually or maybe like direct also. We can do it. That is also possible. And then home-based rehabilitation. So that is what normal balance and coordination exercise like standing on one foot and walking heel to toe, and then using balance board, and the range of motion exercise like arm and leg stretches, therapy ball exercise, and distance band stretches. That also we can do it. So this is recent. This is one kind of a technology is called so single leg or maybe like double leg. Slowly, like with the bar, then they want to keep and slowly they want to walk. It's called parallel bars. Parallel bar. So they will have support and slowly, like with the confidence, they can walk. Also, like this is like home-based rehabilitation. So we can ask them to do it like daily activity. Then we want to ask them to make coffee or tea or something like when they are feeling how they are feeling. daily activity, then we want to regain. And challenges, home-based rehabilitation. So patient safety is very, very important. Regularly, like they want to visit hospital and the physician, they want to check how they are feeling. Community-based rehabilitation. This is what like we can ask the patient to play. So we can ask patient to play in some area like what sports they're liking. So in that area also we can start. And then support and resources, local support group, online forums, or rehabilitation centers, or national organization, or finance support from the funding agency like this, we can get a support. Assistive technology for stroke management also it is available. Robotic devices, speech diagnosis softwares, applications, virtual reality technology for regaining their natural experience and wearable devices. So these all the things are assistive technology for stroke rehabilitation. Robotic devices, speech recognition, virtual reality, and wearable devices. So this is one kind of a robotic system for computer rehabilitation. So when you're coming into this rehabilitation, we want to go for brain signal. So you want to connect with the EEG. So when you are using BC controlled actuators, so you can simply when they are doing some exercise, how their brain is working or functioning, that can monitor. That is called a robotic system for computer rehabilitation. That is also possible. So then maybe I can show us few videos. So you see like manual operation, like how they are holding. So that cup of water, how they are holding. So it's called range of motion, how the finger is moving. These kind of devices, supportive devices can be used. So these kind of devices are available in the market as of now. So it's called opposition motion. Closed loop pressure control. So it can be support for closed loop pressure control. So these are all the support mechanism we can use it for this kind of thing. And closed loop pressure control, same. It is, I mean, single finger, separate finger support. That is also can be done. Likewise, we have so many devices are in the market that can be used for. So one more video you can see. So this is augmented reality. So like this is the purpose of virtual reality. So like they like this, like we can work on with patient to control, like regain their so this is one kind of a device. So and you can see one more neuro rehabilitation centers. So it's because for spinal cord injuries. So likewise, then we have so many technologies. You can say like so these all the such systems are supporting for stroke patients and neuro patients. Okay. So with this, so I will conclude my session. So if you have any questions or something, so you can share right now. Any doubts or something, then you can share. Yes. Any doubts related to this thing? Yes, anyone is available. Just check. So thank you so much for giving me this wonderful opportunity. So maybe any doubts regarding this virtual or maybe like very wearable technologies that you can so ask, we can discuss. Anyone? Thank you. So thank you so much for the opportunity. Thank you, ma'am.
Thank
Any
you.
audible? Any questions, QA also like you can have, like maybe if you're having any doubts, so you can clarify. Any doubts?
So if you have any doubts, kindly ask sir so that we can conclude the session soon.
Yes, I think no one is having any doubts. Thank you, ma'am. Thank you, sir. Thank you, ma'am, for the opportunity.
Thank you, sir.
Thank
It's
you,
a
thank you,
great
sir.
pleasure to once again share your valuable insights and thoughts about the healthcare technologies. Thank you very much, sir.
Thank you, sir.
Yeah, sure. Dear participants, we have a validity session now. Kindly stay online. After that, we need to give feedbacks, and then the test link will be enabled. Meanwhile, we will share the feedback links through the chat. You have to complete all those feedback links compulsorily. Then only the link will be enabled. Thank you. So right now, I have shared 3 links, one for the current session, and session 4 final feedback link is provided so that you have to give all those details, which is essential for the feedback. And then a short video feedback link is also provided. So kindly upload the video in that particular form. Dear participants, you have to fill all those feedback links. Day 6, we have 3 sessions. You have to complete the 3 session links, and then a final feedback link is provided. Along with that, a video feedback link is provided. A short video has to be uploaded with the video feedback link. And session 4 final feedback link, that has to be completed. So once you have completed all those things, after a valedictory session, you can attend the test. Providing a video feedback is essential. So everyone have to upload the video, short video only. So just a few seconds or a few minutes. Short 10 MB video can be uploaded in that file. So everyone has to upload a short video in the feedback form.